Okay, we just finished talking about 2D shapes, so we're going to move on now to 3D shapes, and we're going to call those 3D figures, and you might see those referred to as solids. Okay, so that just means a 3D shape. Real quick, a word that we need to know and be able to think about and talk about is a polyhedron. So a polyhedron is a solid with a flat surface. Okay, so that's like a cube or a cylinder, things that have flat surface. So that's like a cube or a prism, but not a sphere or a cylinder because they don't have flat, they have curved. Anyways, a polyhedron, you'll see that word in your homework and in your test, so just be aware of it. All right, we're going to define two types of polyhedrons. The first one is a prism, and the other one is going to be a pyramid. So we're going to write down some information about prisms and pyramids. We're going to draw some pictures, and hopefully you'll be able to draw some of these pictures, and don't worry if you're not great at it right now. Right now we're drawing a triangular prism, and it's going to be standing up vertically. So take your time, and if you have to pause it to get your pictures right, that's fine. Go ahead and pause it. Okay, so my picture is not great, but here is a prism. And now over here we're going to draw a pyramid. A pyramid is a little bit harder to draw, but we're going to do it anyways. And there's lots of ways to draw them. I'm trying to draw some pretty good ones so that y'all will have good pictures to look at. All right, so here's my pyramid. Now we're going to go around and we're going to label these things. The first thing we're going to label is the bases. So on our prism, this is a base. And down at the bottom, this is a base. Okay, something to know about bases is that a prism always has two parallel, the symbol means parallel, congruent polygon bases. Okay, so sometimes you'll get mixed up about what's the base and what's not the base. Well, the bases are always parallel to each other. So if you look up here in this picture, we have these two bases. We have this top triangle and we have this bottom triangle. Those two triangles are parallel to each other. That makes them bases. Okay, then we have kind of like the sides here, or the flat sides of them. These are called the faces. So this is a face. So it has two parallel congruent polygon bases, and then it has parallelogram faces. Okay, and you might look at that face and say, well, that's a rectangle, and that's true, but a rectangle is a parallelogram, and we'll learn a lot more about that later on in the year. Okay, we're going to write down a couple of formulas for them. The first one, you've done these formulas before, so we're just going to write them down. So S stands for surface area. So the surface area of any prism is always the perimeter of the base times the height plus 2 times the area of the base. So one thing I left off the picture that I need to go back up and put is the height. And this is the height. The height is always, I can write this in here too, height is perpendicular, so that's our symbol, perpendicular to the bases. Okay, so right here, perpendicular. Then our other formula is for the volume of a prism. So this is every prism. All prisms have the same volume formula, and it is the area of the base times the height. Now we're going to come over and label our pyramid. The pyramid's a little trickier, but we're going to get everything where it goes anyways. The first thing is the pyramid has a base, but it only has one base. So it has one polygon base. So we could have a square pyramid, we could have a rectangular pyramid, we could have an octagonal pyramid, but it has to be a polygon on the bottom. It has triangular faces, so face. And I know this is not great labeling, so label it however you need to do it to have it be a good visual for you. Our base is this bottom, and then our face is the actual triangle flat face, and the base is that bottom square parallelogram thing. Another thing that pyramids have that prisms don't have is they have one vertex up at the top. So they have a very tip top. Now these all have a vertex too, right? All these corners are called a vertex, but a pyramid only has this tip top vertex, and it comes into play in some of our drawings and sort of thing. These are also called vertices, vertexes, but the pyramid has that one vertex at the top, so you always look for that point. If it has the point, it's a pyramid. Now the height of the pyramid is here. It's from the vertex straight down to the base, and it's perpendicular. So that, just inside there, is the height. That vertical, it's like a tent pole holding up a tent. Then we're going to add one more line on here that you may have done before and you may not have done. But outside on the face, and this is perpendicular to the face, there's something called a slant height. Okay, that is how tall that triangle is, but keep in mind that triangle is not standing straight up and down, it's leaned over. So the slant height is the height of the triangular face, if that's clear and that makes sense. Alright, so surface area for a pyramid, all pyramids, is 1/2 perimeter of the base times the slant height. The slant height is L, plus the area of the base. And the volume of all pyramids is 1/3 area of the base times the height. Alright, so we're going to move down now and talk about non-polyhedrons. These are solids with curved surfaces. Right? There are 3 of them. There's a cylinder, a cone, and a sphere. So we're going to start out with our cylinder. The easiest way to draw a cylinder is to draw not so much a circle, but kind of an oval. And then from the edges of the oval, draw as straight as you can, and then try to replicate the curve again at the bottom. And then for your top part, you put a little dotted line, and it gives it the impression that it's sunk back behind there. Now, in a cylinder, the bases are circles, so they have a center and they have a radius. So it's important to note that a cylinder has a radius, and it has a height, and it has 2 bases. So this is a base, this is a base. And you can shade those in if you want to give it a little more of a 3D kind of effect, but those are your bases. There's debate back and forth. People argue over whether or not the side around a cylinder is called a face or what it's called. It's kind of like a label of a can. But anyways, the big things you need to know is that a cylinder has two parallel, congruent, circle bases. The formula for the surface area of a cylinder is 2 pi RH plus 2 pi r squared. Should look a lot like the formulas we did on your algebra review where we had you move letters around. Now you know why we were doing that. The volume of a cylinder is area of the base times the height. Now we're going to move on to our cone. So cone is similar to a cylinder in that it has a circular base, but it just has one. I find the best way to draw a cone is to draw the triangle part first and then do the curve at the bottom. And then just do your best to make it look like a oval, or mine looks like an eye, I guess, but that's what you want to try to get. A nice little cone, and it has a circular base which gives it a radius. It has a height that's perpendicular to the base, so it's right here in the center. That's the height. And it also has a slant height, just like the cylinder, or I'm sorry, just like the pyramid. So this height along the slanted side here is called the slant height. So it has one circle base, and then our formula for surface area is pi RL, so pi r times the slant height, plus pi r squared. And our formula for volume is very similar to the pyramid. It is 1/3 area of the base times the height. Okay, so we just got one more picture to draw, and it's definitely the hardest one to make look even a little bit good, so don't judge me. So to draw a sphere, the best thing to do is try to draw a circle, which by itself is hard to do, and then draw like a little oval around the center and hope that you get some kind of 3D effect going. This is not an art class, so you're not going to be judged on your ability to draw spheres, don't worry. The distance around the center of a sphere, the biggest distance, kind of like the equator, we'll get to later. It's called a great circle, which means it's the biggest circle that can go around the sphere, and that's where you measure the radius. Okay, so this is the radius of the sphere. Now, if you went up like this, that would also be the radius, or if you went down, that would be the radius. So everywhere you go in a sphere, it's always the radius. A sphere has no base, no face, no edges, nothing. It's just a sphere. It just has a radius. So the formula for the surface area of a sphere is 4 pi r squared, and the formula for the volume of a sphere is 4/3 pi r cubed. Okay, so all of these formulas you've seen before, and all of these formulas need to be committed to memory. You want to be able to pull these up and use them on a test without hesitation. So that's it. Have a great night.